Linear approximation, also known as local linearity. Our objective is to find and use the linear approximation to a function. Recall the tangent line of a function at the point c, f of c can be written as y minus the y-coordinate f of c equals f prime of c, the derivative of the function at c to get our slope, times x minus c, the x-coordinate. Sometimes it's useful to solve the equation for y, in which case it would look like this after we add f of c to both sides. F prime of c times the quantity x minus c plus f of c. A tangent line can be viewed as a linear approximation to a function at values close to the point of tangency. So sometimes, especially if our function is quite complicated, instead of using the function to find values, we can just use a tangent line where we have a linear equation to approximate function values. The linear approximation, or local linearity, often written as L of x, to a differentiable function f at x equals c is given by L of x equals f prime of c times the quantity x minus c plus f of c, simply the tangent line equation. Example 1. Part A. Find the linear approximation L of x to the function f at x sub naught. F of x equals x cubed minus x minus 3, and x sub naught equals 1. So when they say find the linear approximation, this is another way to say find the equation of the tangent line, or the tangent line equation. What do we normally need for the equation of a line? We need a point and a slope. Right now we only have the x-coordinate. We can plug that x-coordinate into our function to get the y-coordinate. So f of 1 is 1 cubed minus 1 minus 3, which equals negative 3. Now we have a point, 1, negative 3. Next, we need our slope, and the slope is the derivative. F prime of x equals 3x squared minus 1 and minus 0. We want the derivative specifically at our x value, so f prime of 1 is 3 times 1 squared minus 1, which gives us the value 2. Now we write the equation of our tangent line, and we're used to just doing it like this. Y minus the y-coordinate, negative 3, equals the slope, 2, times x minus the x-coordinate, which was given as 1. This can also be written, of course, as y plus 3 equals 2 times the quantity x minus 1. And solving for y, we write y equals 2 times the quantity x minus 1 minus 3. Now they say we want the linear approximation L of x, which just means instead of calling this y, let's call this L of x. So L of x, our linear approximation, equals 2 times the quantity x minus 1 minus 3. And there we have it. Part B. Using the linear approximation L of x, what is the approximate value of f of 1.1? Now they told us right here that we will use the linear approximation L of x. That's this that we came up with from part A. So we're just plugging 1.1 into that tangent line equation, or the linear approximation, or the local linearity. L of 1.1 equals 2 times 1.1 in for x minus 1 minus 3. 1.1 minus 1 is 0.1. 2 times 0.1 is 0.2. And 0.2 minus 3 is negative 2.8. and that is the approximate value of f of 1.1 using our tangent line equation or our linear approximation. Thanks for watching.